Hello students, welcome back to my channel Crack Chemistry. Before starting, I request you to please subscribe my channel and press the like button. I request you to press the bell icon also for getting updates. Children, today I am going to cover a class 11 topic. The name of the topic is quantum numbers. This topic is included in class 11 NCERT textbook part 1. The name of the chapter is structure of atom and this is the second chapter of our NCERT chemistry part 1. So, uh, I'm going to explain you the quantum numbers in a very simple and interesting way. Children, this topic is very important topic from your class 11 point of view, from your next class, as well as from your competitive point of view. And I try to explain all these quantum numbers in a very simple and interesting way. I hope you like this video. So let's see what we are going to discuss today. Children, we will discuss about orbitals and quantum numbers. Then we will see the four different type of quantum numbers, which are principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, and in the last we will see the informations provided by four quantum numbers, followed by questions based on the topic taught. So in the last we will solve some questions based on the topic. So first of all we will see what are orbitals and what are quantum numbers. Children, a large number of orbitals are possible in an atom, and these orbitals can be distinguished by their size, shape, and orientation. Then, an orbital of a smaller size means there is more chance of finding the electrons near the nucleus. And if an orbital is of larger size, it means it is present away from the nucleus. Similarly, shape and orientation means that there is more probability of finding the electron along certain directions than along others. So, quickly I want to revise these points, whatever I have discussed. In an atom, a large number of orbitals are present, and these orbitals can be distinguished by their size, shape, and orientation. A smaller size orbitals means it is present closer to the nucleus. Then an atomic orbital is precisely distinguished by the quantum numbers. There are three main type of quantum numbers which describe an atomic orbital. These quantum numbers are labeled as N, L and M. N represents the principal quantum number, L represents the azimuthal quantum number, and ML represents the magnetic quantum number. So one by one we will discuss all these quantum numbers. First is a principal quantum number. Principal quantum number is a positive integer with which have the values 1, 2, 3 and so on. Then what does a principal quantum number determines? It determines the size and to the large extent the energy of the orbital. So it determines the size and to the large extent energy of the orbital. But one point you have to keep in your mind that for hydrogen atom and hydrogen-like species like He plus, Li2 plus, what is the characteristic of these species? They have one electron. Hydrogen atom has one electron, and the hydrogen-like species like He plus, Li2 plus, they also have one electrons. So for hydrogen atom and hydrogen-like species, energy and size of the orbitals depends only on the value of N. But in the case of multi-electron atoms, apart from N, there are some other factors on which the energy and the size of the orbital depends. These points we will discuss in the today's video only. Then the principal quantum number also identifies the shell. If N is equal to 1, it means shell number is 1. So N is equal to 1 represents the first shell. N is equal to 2 represents the second shell. N is equal to 3 represents the third shell and so on. Now the next point is that with the increase in value of N, the number of allowed orbitals also increases and given by N square. So if you know the value of N, you can calculate the number of allowed orbitals present in that shell. So N represents the number of shell, and from the value of N, you can calculate the number of allowed orbitals present in that shell. So for example, if N is equal to 1, it will have how many orbitals? 1 square means 1 only. So N is equal to 1 means first shell consists of 1 orbital. if n is equal to 2, n is equal to 2 means allowed orbitals will be equal to 2 square. 2 square means 4. So second shell consists of 4 orbitals. Similarly, n is equal to 3 means third shell. Third shell consists of 3 square means 9 orbitals. So we can say that principal quantum number determines the number of shells, and with the value of principal quantum number we can also calculate the number of allowed orbitals present in a shell by using the formula n square. Then all the orbitals of a given value of n constitute a single shell of atom. I mean to say that 4 orbitals which have the value n is equal to 2, they constitute the second shell. They constitute the second shell. Similarly, the one orbital with the value of n is equal to 1, it constitutes the first shell. Then all the 9 orbitals with value n is equal to 3, they constitute the third shell. Then so same point I was discussing, all the orbitals of a given value of n constitute a single shell of atom, and they are represented by the following letters. N is equal to 1. First shell can be represented by the letter K. Second shell can be represented by the letter L. Third shell can be represented by the letter M. Fourth shell can be represented by the letter N, and so on. Then another important point, size of an orbital increases with the increase of principal quantum number. So if n is equal to 1 and n is equal to 5, the orbitals present in the fifth shell, they will be of larger size than the orbitals present in the first shell. In other words, the electrons will be located away from the nucleus. It's quite obvious that if the value of n increases, it means the electrons will be located away from the nucleus. Now, another important point is that as the electron is negatively charged particle and it is attracted by the positively charged nucleus by electrostatic forces of attraction. So, to shift away the negatively charged electron from the influence of the positively charged nucleus, we need to provide energy. So always remember, the energy of the orbitals will increase with the increase of the value of n. I hope these points are clear to you. So we can summarize these points. N represents the principal quantum number. And how many values n can have? It can have the values, it's a positive integer 1, 2, 3, and so on. What does n represents? N represents the shell. That is the first point. So if n is equal to 1 means first shell, n is equal to 2 means second shell, n is equal to 3 means third shell. And then n also represents the number of allowed orbitals. N also represents number of allowed orbitals, which can be given by the formula n square. So if n is equal to 1, the allowed orbitals will be equal to 1 square means 1. So first shell consists of only one orbital. If n is equal to 2, the allowed orbitals will be equal to 2 square means 4. So second shell consists of 4 orbitals. N is equal to 3. Allowed orbitals will be equal to 3 square means 9. 9 orbitals will be there. So these are the informations which we got from the principal quantum number about the number of shells, about the number of allowed orbitals, and it represents the size also. It represents the energy of the orbital also. So all these informations we are getting from the principal quantum number, which we have discussed in detail. Now, second quantum number is the azimuthal quantum number, which is represented by the symbol n. So children, this azimuthal quantum number is also known as orbital angular momentum quantum number or subsidiary quantum number. Then the question arises, what does it defines? It defines the three-dimensional shape of the orbital. So for a given value of n, L can have n values. This is a very important point. For a given value of n, L can have n values. For example, if n is equal to 1 means n has one value, then L will also have one value, and these values range from 0 to n minus 1. So values of L are equal to the values of n, but these values range from 0 to n minus 1. So n is equal to 1. L also has one value, From where this value will start? 0. So n is equal to 1, L is equal to 0, and children remember that this value represents a subshell which is represented by the symbol 1s. 1 represents the n principal quantum number and s represents the 0 value of L. So L is equal to 0 represents the s subshell. Now we can write one more point here. If n is equal to 2, so L will also have two values. What are these values? Start from 0. The values will start from 0 and will end at n minus 1. So what is n minus 1? 2 minus 1 is 1. So again, as I told you, L is equal to 0 represents the subshell, S subshell, n is equal to 2 represents the main shell. So the subshell can be designated as 2s. Similarly, n is equal to 2, L is equal to 1. So L is equal to 1 represents the P subshell. So we can see here that second shell consists of two subshells which are 2s and 2p. So we can conclude that values of L are equal to the values of n, and these value ranges from 0 to n minus 1. So the same point I want to explain here. If n is equal to 1, L can have only one value, that is 0. Then if this 0 represents the, what does it represent? It represents the subshell. With subshell N1 L0 means 1s subshell. If n is equal to 2, there are two possible values of L, 0 and 1. The values also always start from 0 and end at n minus 1. So n is equal to 2. So first value will be 0 and n minus 1 means 2 minus 1 means 1. So 0 always represents the S subshell, but n is equal to 2, so it will represent the 2s subshell. Again, n2, but L is equal to 1, 1 always represents the P subshell. So n is equal to 2 means second shell consists of two subshells which are 2s and 2p. N is equal to 3. The possible values are 0, 1 and 2. Again 0 represents the S subshell, 3s, and n is equal to 3, L is equal to 1 represents the 3p subshell, n is equal to 3 and L is equal to 2 represents the 3d subshell. Now, each shell consists of one or more subshells or sublevels which I discussed just now, like first shell consists of only one subshell. The second shell consists of two subshells, 2s and 2p, and so on. Then the number of subshells in a principal shell is equal to the value of n. I told you, I explained you just now, if n is equal to 1, the number of subshell is also only 1, that is 1s. If n is equal to 2, the number of subshells are also 2, which are 2s and 2p. If n is equal to 3, the number of subshells are also 3, which are 3s, 3p and 3d. Children, I hope these points are clear to you. So again I am explaining the same point. If in the first shell value of n is equal to 1, there is only one subshell with corresponds to L is equal to 0. So what is this shell? The shell will be 1s. There are two subshells. For these two subshells, the values are L is equal to 0, L is equal to 1 in the second shell. So second shell N2L0, again I explained you just now, the subshell is 2s, and 2L1 the subshell will be 2p here. Similarly, if I am talking about the third shell, for third shell n is equal to 3, how many values of L will be there? L will have three values, 0, 1 and 2. So L is equal to 0 will be with subshell, n is equal to 3, L is equal to 0, 3s subshell. N is equal to 3, L is equal to 1 will be 3p subshell. N is equal to 3, L is equal to 2 will be 3d subshell. So each subshell is assigned a quantum number L. I mean to say that S subshell is assigned the quantum number 0, P subshell is assigned the quantum number 1, and D subshell has been assigned the quantum number 2. I hope these points are clear to you. So subshell corresponding to different values of L are represented by following symbol. If the value for L is 0, the subshell will be S. And or we can say value of L is 1, subshell P. Value of L is 2, subshell D. Value of L is 3, subshell F. Value of L is 4, subshell G. If value of L is 5, subshell will be H. So now with the help of this table we can explain this point again. N is equal to 1, there is only one value of L, that is 0, and the subshell will be designated as 1s. N is equal to 2, you have two values of L, they are 0 and 1, so N2L0, 2s subshell, and 2L1, 2p subshell. So we can say that in N is equal, in the second shell, how many subshells we have? We have two subshells in the second subshell. Now, I'm just coming back to the same point. If N is equal to 3, you have three values of L0, 1 and 2. So N3L0, 3s subshell, N3L1, 3p subshell, N3L2, 3d subshell. So we can say that third shell has how many subshells? 3 subshell. 3 subshells. Similarly, first shell has only one subshell, that is 1s. Now I am coming to the fourth shell, N is equal to 4. Four values of L are possible here. They are 0, 1, 2 and 3. N is equal to 4, L is equal to 0, 4s subshell. N is equal to 4, L is equal to 1, 4p subshell. N is equal to 4, L is equal to 2, 4d subshell. N is equal to 3, L is equal to 4, 4f subshell. So we can conclude that fourth shell consists of 4 subshells. Fourth shell consists of 4 subshells. I hope these points are clear to you. Now I just want to revise all these points whatever we have discussed, children. The value L represents the azimuthal quantum number. The values of L depends on the value of N. L can have N values, and these values start ranges from 0 to n minus 1, and the values of L represents the subshell. If n is equal to 1, L will have only one value, that value will start from 0, and the subshell can be represented as 1s. If n is equal to 2, then again L will have two values which will start from 0 to n minus 1, so 0 and 1. So n is equal to 2, second shell, and L is equal to 0 is the S subshell. So 2s subshell. N is equal to 2 and L is equal to 1. The subshell will be 2p. So we can say that N is equal to 2. Second shell consists of two subshells which are 2s and 2p. Similarly, we can write N is equal to 3. L will have three values, 0, 1 and 2. So N is equal to 3, L is equal to 0, 3s subshell. N is equal to 3, L is equal to 1, 3p subshell. N is equal to 3, L is equal to 2, 3d subshell. So third shell consists of 3 subshells. Third shell consists of 3 subshells. Second shell consists of 2 subshells. And first shell consists of only one subshell. So we can conclude that L represents the number of subshells present in a shell, and the number of subshells are always equal to number of N. Now I want to discuss the next quantum number, which is the magnetic orbital quantum number. It is represented by the symbol ML. Children, ML gives information about the spatial orientation of the orbital with respect to standard set of coordinate axes. So ML gives us information about the spatial orientation of the orbitals, or simply we can say that how many orientations are there, that many number of orbitals are present in a subshell, or in a very simple way we can say that ML, magnetic orbital quantum number, gives us the number of orbitals present in a subshell. Then for any subshell, we have already discussed subshells are defined by the value L. For any subshell, 2L plus 1 values of ML are possible, and these values can be represented as minus L minus 1, minus L minus 2, 0, 1, L minus 2, L minus 1, and finally L. Or simply we can say that for any subshell which is defined by the value L, ML can have the values can be written as minus L, 2 plus L, through 0. So it can have the value minus L, then 0 to plus L. Now, so again, in a very simple way, I want to explain you that ML represents the magnetic, ML is the magnetic orbital quantum number. It gives us about the number of orbitals present in a subshell. N gave the information about the shell, L azimuthal quantum number about the subshell, and the ML, which is the magnetic orbital quantum number, informs us about the number of orbitals present in a subshell. So, for L is equal to 0, the only permitted value of ML is equal to 0. And by substituting this value in the formula 2L plus 1, we are going to calculate how many orbitals are present. So, 2L plus 1. So, what is L here? L is 0 here. So, 2 into 0 plus 1 means only one value. So, what does it mean? L is equal to 0 means S subshell, and this one value indicates that only one orbital is present in the S subshell. Similarly, we can calculate for L is equal to 1. How many values are for ML are possible? Minus 1, 0 and plus 1. So what we will do? We will substitute the value in the formula 2L plus 1. 2 into 1 plus 1, we will get 3. So it means L is equal to 1 means P subshell. P subshell has how many orbitals? 3 orbitals. Similarly, for L is equal to 2, the values of ML will be minus 2, minus 1, 0, plus 1 and plus 2. So substitute the values in the formula. We will have 2 into 2 plus 1 is equal to 5. It means 5 d orbitals are possible. For L is equal to 2, the subshell is 5. Subshell is d. So d subshell has 5 orbitals. Now it must be noted that the values of ML are derived from the values of L, and the values of L are derived from the values of N. We have already discussed. Now, each orbital in an atom therefore is defined by a set of values for N, L and ML. So, we have seen that any orbital can be defined by a set of 3 quantum numbers which are N, L and ML. For example, an orbital is described by the quantum number N is equal to 2, L is equal to 1 and ML is equal to 0. What does it mean? N is equal to 2 means shell is the second shell. L is equal to 1, L is equal to 1 means this is the P subshell. So ML is equal to 0 means we are talking about an orbital which is present in the second shell and the P subshell. So we can conclude that quantum numbers give the complete address of electron in an atom. Then following chart gives the relationship between subshell and the number of orbitals associated with it. So value of L0 means S subshell, already you know. S subshell has how many orbitals? Only one orbital. Then value of L is equal to 1. So one value of L represents a P subshell, and P subshell has 3 orbitals, minus 1, 0, plus 1. L is equal to 2 means D subshell. D subshell has 5 orbitals, means minus 2, minus 1, 0, plus 1 and plus 2. L is equal to 3 means F subshell. How many orbitals are there? 7 orbitals are there. Minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Then N is equal to 4 means, L is equal to 4 means G subshell. How many orbitals? 9 orbitals. L is equal to 5. S subshells. How many orbitals? 11 orbitals. So children, I hope all these points are very clear to you. So in a simple way, I want to revise all these points. ML represents number of orbitals in a shell, number of orbitals in a subshell. Number of orbitals in a subshell. And the values of ML, maximum values of ML will be equal to 2L plus 1, and the values can be represented as minus L to plus L through 0. I mean to say, if N is equal to 1, L will have only one value, that is 0. So ML will also have only one value, that is 0. So what is this value? We can get the value from the formula 2 into 0 plus 1. 2 into 0 plus 1 means only one value ml has for L is equal to 0, that value is 0. So it means that n is equal to 1 means first shell, L is equal to 0 means S subshell. So this is the 1s subshell. S subshell has only one orbital. So children, magnetic quantum number informs us about orbitals, number of orbitals present in a subshell. N is equal to 2. L will have two values, 0 and 1. So L is equal to 0, N is equal to 2, 2s subshell. What will be the value of ml for L is equal to 0? That will be 0. 0 means 1 orbital. Now I am coming to the next, N is equal to 2. L is equal to 1 with subshell 2p subshell. But if L is equal to 1, ml will have three values. What are these three values? Minus 1, 0, plus 1. It means the second subshell has, the p subshell has three orbitals. So we can conclude here that second shell, this is the second shell, n is equal to 2 means second shell consists of how many total orbitals? One orbital here and three orbitals here. So we can say that total of 4 orbitals. So second shell consists of 2 orbitals. Now I want to discuss about the last quantum number, which is the electron spin quantum number. The three quantum numbers which we have discussed just now can be used to define its energy, shape and orientation. But all these quantum numbers are not enough to explain the line spectra observed in the case of multi-electron atoms. Children, in the case of multi-electron atoms, their line spectra consists of some lines which actually occur in doublets. Doublet means there are two lines which are closely spaced. Triplets, there are three lines which are closely spaced. So these doublets and triplets suggest the presence of a few more energy level than predicted by the three quantum numbers. So in 1925, George Uhlenbeck and Samuel Goldschmidt proposed the presence of the fourth quantum number, which is known as electron spin quantum number. It is represented by the symbol ms. So an electron spin around its own axis in a similar way as Earth spin around its own axis while revolving around the sun. So we can say that electron, besides charge and mass, has the intrinsic spinning angular quantum number also. So spin angular momentum of the electron is a vector quantity and can have two orientations relative to the chosen axis. These two orientations are distinguished by the spin quantum numbers, which have the values plus half and minus half. So, and in a simple way, we can say that apart from these three quantum numbers which we have discussed in detail, electrons also can be represented by their spin, and this is represented by the fourth quantum number, which is the spin quantum number. So an electron, while revolving around the nucleus, revolve around its own axis in two ways, which are clockwise and anti-clockwise. They are represented as plus half or minus half, or they are represented by two arrows, spin up and spin down, upward arrow and the downward arrow. So two electrons that have different ms values, one is having plus half and the other is having minus half, are said to have opposite spins. So one more very important point, an orbital cannot hold more than two electrons, and these two electrons should have opposite spin. So if there are two electrons in 1s orbital, because 1s subshell consists of only one orbital. One orbital means how many electrons? Two electrons. So out of two electrons, one will have plus half spin and the other will have the minus half spin. Now, just now we have seen that an orbital cannot hold more than two electrons. Children, previously we have studied that in a shell, number of orbitals equal to n square, and an orbital can accommodate two electrons, so number of electrons in a shell will be equal to 2n square. I hope these points are clear to you. In the last, we will sum up all these points we have discussed and defines the shell, and it determines the size of the orbital and to the large extent the energy of the orbital. So n defines the shell, size of the orbital and the energy of the orbital. And there are n subshells in the nth shell. I explained this point previously. If I'm talking about the first shell has the one subshell only. Second shell has the two subshells, 2s and 2p. So there are n subshells in the nth shell. L identifies the subshell and determines the shape of the orbitals. Then there are 2l plus 1 orbitals for each type in a subshell, that is 1s orbital for L is equal to 0. L is equal to 0 means what is the subshell? S subshell. And S subshell consists of only one orbital. And there are 3 p orbitals for L is equal to 1. The orbitals are 3 p orbitals are there, which are represented as -1, 0 and +1. And there are 5 d orbitals. For d orbitals, L is equal to 2. So number of orbitals will be 5, which are represented as -2, -1, 0, +1 and +2. So we can say that to some extent L determines the energy of orbitals in a multi-electron atom. Then we are coming to the third quantum number ML. ML designates the orientation of orbital, or in a simple way we can say that it represents the number of orbitals. For a given value of L, ML has 2L plus 1 values. It means it has 2L plus 1 orientation and 2L plus 1 orbitals. So we can say that for a given value of L, ML has 2L plus 1 values, the same as the number of orbitals per subshell. It means the number of orbitals is equal to the number of ways in which they are oriented. Finally, I am coming to the last quantum number, which is MS. MS refers to the orientation of spin of the electron. So MS represents that an electron is moving clockwise or anti-clockwise. Now, I want to discuss some of the numericals based on the topic. So, first question is that what is the total number of orbitals associated with the principal quantum number n is equal to 3. So, children, already we have discussed that number of orbitals can be represented by the formula n square. So, if n is equal to 3, the number of orbitals will be equal to n square, that is 9. So, 9 orbitals are possible. 9 orbitals are associated with principal quantum number n is equal to 3. Then the second question is that using SPDF notation, describe the orbital with the following quantum numbers. If n is equal to 2, L is equal to 1, children, L is equal to 1 represents the p subshell. So how you will describe the orbital? That will be the 2p orbitals. Then n is equal to 4, L is equal to 0. Again, you know that L is equal to 0 represents the S subshell. The orbital designation will be here as 4s. Now, n is equal to 5, L is equal to 3. So, children, n is equal to 5 represents the 5 shell, and L is equal to 3 represents the subshell. Which subshell? F subshell. And n is equal to 3, L is equal to 2. It represents L is equal to 2 represents the D subshell, L is equal to 3 represents the F subshell. I hope these questions are clear to you. Now the next question is that an electron is in one of the 3D orbitals. Give the possible values for N, L and ML for this electron. So children, 3D orbital means N is equal to 3 and L will be, you know that value of L depends on the value of N. So L will have three values 0, 1 and 2. 0 represents the S subshell, 1 represents the P subshell, but here in the question we have been given D orbital. So what is the value of L? The L value will be L is equal to 2. So our answer is that the N is 3, L is equal to 2, but they are asking about the ML also. So now children, you know that the value of ML depends on the value of L, which can be written as -2, -1, 0, +1 and +2. So ML value can be any of these 5 values the electron may have. So N is equal to 3, L is equal to 2 and M can be -2, -1, 0, +1 and +2. Now, one more question I want to discuss here. How many electrons in an atom may have the following quantum numbers? So, in the first question, we have n is equal to 4, but ms is equal to -12. So, n is equal to 4 means we are talking about the fourth shell. Children, you know that. Fourth shell means number of orbitals will be n square. Orbitals will be n square. N square will be 16. Now, orbitals will be 16 and number of electrons will be 2n square. 2n square means 2 into 16. The fourth subshell will have 32 electrons. But children, already you know that an orbital can accommodate 2 electrons. So 16 orbitals can accommodate 32 electrons, but an orbital has 2 electrons with opposite spin. And in a question we have ms is equal to minus half. So out of 32 electrons, only 16 electrons can have minus half spin and remaining 16 electrons will have plus half spin. So what is the answer? How many electrons can have these quantum numbers? Our answer is only 16 electrons. Now I want to discuss the next question. N is equal to 3, N is equal to 0. So this represents the 3s subshell. You know that 3s subshell, S subshell has only one orbital. And one orbital can accommodate 2 electrons. So how many electrons can have this value? Our answer is 2 electrons. Now, in the last, I just want to conclude that whatever we have discussed today, we have discussed about orbitals and quantum numbers. We have discussed the principal quantum number, azimuthal quantum number. Then we studied about the magnetic quantum number. Then we studied spin quantum number. We have seen the informations provided by 4 quantum numbers. And in the last, we have solved some questions based on the topic taught today. So I hope all these points you have understood very nicely. Thank you so much for watching this video. Children, please subscribe my channel and like this video. In case if you have any doubt, then post your doubts in the comment box. I'll explain your doubts. I will clarify your doubt as soon as possible. Thank you so much. Have a nice day.